everyone. Hi, everyone. It's Nat here from the NextWork team. It's good to see everyone here. We've got Rishabh already. We've got Derek. Good to see you both. It's Nat here. I'm going to go kick off my screen share so you can check out my NextWork project as well. But today we're going to be learning something called Code Graph together, and we're going to be using a NextWork project to learn it. So I'm really looking forward to this. I've never used Code Graph before, but I've heard some great things. And oh, are we still at no audio right now? Utkarsh, can you hear me okay? Cool, I hope you can hear me okay. So we'll be learning Code Graph together, and I've got NextWork open in front of me right now. Oh, yeah, people are asking me if my mic is on. Yes, it is on. Hello, can you hear me okay? Can you hear me okay? Hello, hello? Oops, I think we've got audio issues right now. Let me just double check that everyone can hear me okay before we keep going. Hello, hello? Okay. I will leave the event and come back. That's so funny. I'm gonna leave the Discord event and be right back. Hello? Hello, hello? Oh, is audio working? Hey, audio works. Thank you, Maya, for letting me know. We just needed to leave the chat and come back. Ah, well, I'm glad. I'm glad everyone can hear me now. So what I'm gonna do is I'll kick my screen share back on so everyone can see my screen. I've got the beautiful NextWork app in front of me. And before we kick off today's project, I thought I'd do a quick shout out of a feature that just dropped literally an hour ago. So this might be new to you. So when you click on your library, you might remember that this used to be a space for you to check out, projects that you saved and look at what you can see now. When you click on your library, not only can you see your recently viewed projects, but you can now actually see projects that are all authored by you, all your liked projects, all in progress, all completed, and there's more coming soon as well. The cool thing about a portfolio is that you can now share this as well with someone else. So what I'm going to do is share my portfolio in the chat. I'd love to see everyone's portfolios. It's such a cool way to see a collection of all the projects that someone else has created, all the projects that someone is following, projects that I'm working on. This is me exposing myself that I have 43 in progress. And then 32 that I've completed. Pretty cool. I have to say, I think my actual project completion should probably be a bit higher than this. But I have a feeling all of them drop back into in progress state because I always redo projects. um, but I'm super stoked by this. Today we're going to be bumping up the number of projects I've authored by one because we are about to generate a project together. We're going to learn about Code Graph, which is something completely new to me. I only learned about Code Graph literally this morning, so I'm excited to do something hands-on with it. What better way to learn a new tool? So we're going to first jump straight into the generation process, but soon after that, we'll also read the article that the project's going to be inspired by, so we can also learn what CodeGraph does together. Now, I can't wait to see everyone's portfolios. Please take a minute to like check in your portfolio link. I would love to see yours. Um, in the meantime, I hope you're all taking care of yourselves today. It's the evening here in the US, or the morning if you're like in Asia. So I hope wherever you are having a great time. Today, we're going to learn about CodeGraph. And I got inspired by CodeGraph from an article that I read. So what I'm going to do is generate a project based on that article. All right, and I'm going to type into here, I learned about a new tool called CodeGraph. I'd love to do something hands-on with it. And I just pasted the link to that article that I read. And I'm going to click on generate and generate that project. All right. I really love seeing this thought process draw out. The user wants to do a hands-on project with a tool called CodeGraph that they found on Medium. Yeah, great. I now have a thorough understanding of CodeGraph. It's a really cool tool. Sure is, guys. I think I've picked a good one for us today. It says, it pre-indexes your code base into a knowledge graph so that AI coding agents like Claude Code can query structured relationships instantly instead of scanning files from scratch every session. The result is dramatically fewer tool calls, lower token costs, and faster responses. That is a great summary of, I would say, CodeGraph in a more technical sense. I think if I were to explain what CodeGraph is in kind of the terms that I know it best, it really is a tool that basically helps AI coding agents get up to speed on your code base a lot faster. So one of the things that's very expensive about using AI coding agents is the amount of context that it might need to understand a code base and how to perform I guess, the best solution for something that you want to do. The better you understand a code base, the better you can implement solutions. And so typically, coding agents try to do a lot. They are spinning up a lot of different tool calls, which are basically functions that these coding agents can do, just to try to understand your code before they even write a single line of code themselves. But when it takes so much time and so many tokens, it's actually quite an expensive task. So CodeGraph is one of those tools that can help bridge that gap between an AI coding agent and your code base. It tries to shorten the distance that an AI coding agent has to walk through just to understand your code. So I learned about it through a Medium article today, and I'd love to do something hands-on with it. And so the initial direction for our project. Oh, Maya says, see you guys soon. Good night to those in the Americas. Enjoy the live. Gracias. Thank you, Maya. I hope you have a great evening. And yeah, Utkarsh asks, when's dark mode dropping? My eyes are so red. Please save us and release it soon. Oh, yes, Maya says we hear you. There are things we need to do before to make it happen. That is very, very true. But every time someone says dark mode, we promise we actually take a screenshot of it and we share it with the whole team. We're like, look, this one more person that's excitedly waiting for dark mode, so we never forget. So I appreciate you mentioning it, Utkarsh. All right. Well, I'm excited about this. Let's set up CodeGraph on a real open source code base and use it with Claude Code to see the difference firsthand. The project would have you install CodeGraph, index a meaningful code base, run queries both with and without CodeGraph, and observe the efficiency gains. This way, you'd actually experience the exploration tax problem and then see it solved. So are we already using Claude Code? All right. The CLI tool, not just Claude in a browser. Yes, we are using Claude Code. So I'm going to just say yes. Next question. Do you have Node.js installed? CodeGraph can install without it. Hey, I don't know if I have it, so I'm just going to write I'm not sure. Is I'm not sure a reasonable answer. Has anyone else ever written out like I don't know to like a exploration question when they're generating a project? Because I'm definitely asking that already. And do you have an existing code base you like to index, or would you prefer to use a well-known open source repo? Oh, I would love to use a well-known open source repo. Let's use a well-known repo today. 4. Experience level. How comfortable are you with the terminal and MCP? Just want to pitch the project at the right level. Well, I kind of wish there are descriptions of the different comfort levels we could pick from so I could, you know, just pick one out of 4 options. But for now, let's just give an ambiguous comfortable response and see how they interpret it. But let's send that through and see what happens to our generated projects. Man, I'm excited. I wanted to give a big shout out to everyone joining. We've got Shane here. We've got Sexy Joe. Hi, nice to meet you. We've got Sean, of course, Derek, Rita, Utkarsh. It's great to see you. We're doing a project on CodeGraph today. So I read an article on CodeGraph just this morning, and I was really looking forward to using it in hands-on. So that's where we are now. We're still generating the project, so we have not kicked it off yet. But once it's generated, I'll make sure that I chuck that project straight into the chat so we can be working on it together. Shane says, "Don't be so modest. You're a master coder." Until you take away Claude Code for me, and then I might look a little silly. Not gonna lie. Sean says, "What's up, Nat?" It's going great, Sean. The week has been awesome. I think you've probably met Rita by now. Rita joined us and started with us on Monday. And so now, whenever people ask me, "How's your week been?" I do this a lot because I've been meeting with some great people, while trying to grow the NextWork team. I always mention it. I'm like, "Oh, we had someone new join us. Rita's awesome." We're so like it always, brings a new energy. Everyone's so excited. So it's been great. It's been really good. Okay, so I think we're getting close with our project. We are thinking of creating a project called Supercharge Claude Code with CodeGraph. We're going to install CodeGraph, index the Excalibur code base. Has anyone used Excalibur? It's such a great tool. I'm so surprised and touched that the project generator decided to pick Excalibur. It's actually a tool that I'm using in every single technical interview right now. And so to see it come out here gave me goosebumps a little bit. But we're going to run an architectural question with and without the knowledge graph created by CodeGraph, so we can see, ideally, that our coding agents are a lot more efficient when there's CodeGraph, when there's a CodeGraph knowledge base or a knowledge graph already created. Exciting. So the narrative arc is we're going to install CodeGraph and clone Excalibur, and then we're going to ask Claude Code a structural question and watch it burn token scanning files, which is what we're going to call the exploration task. Then we're going to build our knowledge graph using CodeGraph, and this ideally should reduce the exploration tax. So if we ask the same question with CodeGraph active, we should see a dramatic difference. Looks like we've got some extensions as well. We're going to use CodeGraph's code intelligence tools called Impact Radius, callers, and affected tests. Then finally, for our secret mission, we're going to wire CodeGraph affected into a Git hook for smart test selection. I've got to say, these 2 sentences are losing me a little bit. I am finding that the storyline was very clear. And then these 2, I'm like, what? What is going on? If someone knows what wire CodeGraph affected into a Git hook for smart test selection means, you got a big brain. I'd be very impressed. And the good news is CodeGraph standalone installer doesn't require Node.js. Oh, it bundles its own runtime. Everything is free and 100% local. We're going to be doing this for free today. That's great news. This feels good. I would personally say that we'll keep steps 4 we'll keep steps 5 and 6 fairly light because I think steps 1 to 4 should be the main focus of our project, and I like it to focus on making sure those 2 steps are really good. So, please keep steps 5 and 6 light so we can focus more on a great steps 1 to 4 is my request. Awesome. Aw, thank you, Roy, for the kind comment. Roy says, "Net is the mass of everything." Damn, wait till you try watch me swim. I don't think anyone's ever watched me swim before for a very good reason. Um, Frita, aw, that's such a cute emoji. Um, that's so sweet. We've got Glitch Hunter and Jaden in the audience today. Hey, it's great to see you both. Jaden, I've heard such great things about you. I hope you're enjoying building with Sean over in Houston. And Glitch Hunter, it's good to see you. I remember you from our last live together. Um, and I'm excited to build something new with you today. All right. It's going good, Jaden. It's going good. It's great to see you. And we are in the middle of generating a new project called CodeGraph. And let's see whether I think this is probably the last step now before we actually create the project itself. Look at our project generator thinking lots right now. What is it going through? It is thinking about the structure, it's writing out the steps. That sounds great. Oh, and it's collapsed the thought process, but I do want to read it. Um, Interesting. Our project generator is really thinking through the details of the steps right now. For example, this is mostly a CLI and tool setup project rather than a code writing exercise. That's true. How does Excalidraw render and update canvas elements? Wow, there's some very specific questions here. I need to verify the Excalidraw repo URL. That's true, because we're going to need to clone this repo very soon. So it's good to see that it's making sure that this repo actually exists and it's the correct URL. What else can we see here? We can see here that there are some different setup instructions that are possible. So we can install the CodeGraph CLI and clone Excalidraw repository. How do we do that? Ooh, okay, then it's finally mapped out the full structure. But I think it's read my prompt for keeping the project, the last 2 steps light. I hope it's noticed that. It does say for the secret mission, it's gonna keep it focused, which I love to hear. So it wouldn't be too big of a secret mission. Um, Now it's generating the outline. I love to hear it. That's a great milestone when you're generating a project. Um, the outline is basically the final piece in the puzzle that says, are we happy with this? It's going to be what steps 1 to 5 or steps 1 to 6 and the secret mission will look like. Are you ready? And wow, we've got a project outline ready to go. So let's read it together. I'm going to zoom out just a tiny bit so that everyone can read more of it. All right. So the project outline says supercharge Claude Code with CodeGraph. It should take 40 minutes, cost $0 because CodeGraph is free. And we will just expect normal Claude Code token usage. First of all, there's going to be some setup. So be prepared to install CodeGraph and clone Excalidraw, which is that open source repo that we're going to be using. We're going to be using and exploring today. And step 2 is going to be the exploration text. We're going to explore basically how it feels to use a coding agent to explore a completely new code base on your own without any special tools like CodeGraph. And then number 3, we're going to build basically that middleman between our coding agents and our code base. That middleman is that knowledge graph. So we're going to create that knowledge graph using the tool CodeGraph. So once the knowledge graph is built, then we're going to see the effects of that in steps 4 called the payoff. we're going to ask Claude Code another structural question, but instead of it costing a lot of exploration tax to answer that question, it should cost a lot less time, a lot less tokens, because it's now going to actually find its answer and get to know our code base through the knowledge graph instead, which should actually shorten the path to an answer. Then I think we're going to do some extension exercises with code intelligence from the CLI. So we've got a secret mission coming up. I hope we get some time and space to work on that too. But the outcome is exciting. We're going to finish with CodeGraph, permanently integrate it into our Claude Code workflow, giving every future session instant access to pre-indexed code intelligence instead of very expensive file scanning. So let's go ahead and create our project. I think that sounds super exciting. It's going to go ahead and just build that now. In the meantime, I think we've got some cool messages in the chat. Sean says, "Are you a stealth swimmer?" No, I'm so sorry. I'm absolutely not a stealth swimmer. I'm the opposite of a stealth swimmer. I'm a struggle swimmer. I'm very bad at swimming. Did you know? Fun fact about me is I got put into like swim school, which is this class where they pull out kids from PE class, regular PE class, and they put us into a specialized like swimming program to try to teach us how to swim. It's a huge thing in New Zealand. It's a huge survival skill that everyone should know how to swim, because if you can't swim and New Zealand's literally 2 islands, then you're in big trouble if things, natural disasters happen and you need to swim your way out of it. Um, but, I was on that program for 2 years. I had a dedicated, like, teacher that was teaching me alongside 8 other kids how to swim, and we had to be put into this class, and we had to swim at least once a week. Um, but even after doing that for 2 years, I don't think I passed that swimming test with flying colors. I got better. I genuinely did improve, but my swimming is I would not count on it as survival swimming skills. Um, so very unfortunate. No AI for swimming? Asked Shane. You know, the day we do that, the day I will truly believe that AI will solve every problem. I'm joking. I feel like there should be an AI for swimming. Look, if we've got AI cars, I sure as heck would rely on AI to give me some AI fins. That gets me swimming. Um, oh, Jaden asked a great question about someone that I'm connected with on LinkedIn. And yes, someone that I know, someone that I just got connected with when we moved to Austin. Shout out to that person. Didn't want to say that name out loud just because it's recorded in case we want to protect this person's name. But he's awesome. And we actually caught up in person once. We invited him to come check out HQ when we were hosting a barbecue night, and he came along. I'm so excited to hear that you know him too. That's lovely, Jaden. Um, Roy says about my swimming skills. Roy says, "Don't feel bad, Nat. I was a great swimmer. I sink like a rock now." What happened? When's the last time you swam, Roy? What happened? um, so funny. Thanks so. It actually does make me feel a lot better. To know like I'm not alone in the way my swimming has absolutely regressed. Do you know what else has regressed? My driving skills. But let's not talk about that one. It gets worse. Um, all right. Well, the project's getting generated. We're in the writing part now, and I have to say, writing is probably the part that takes the longest. So I wonder how long this part's going to take us. Um, okay, so we've got a 30-second summary. Today, we're going to supercharge Claude Code with CodeGraph. And this is a great summary of what we're planning to do. Problem. Every time you ask an AI coding assistant about your project, it starts from scratch. It greps. Grep is basically a tool or a function that an AI coding assistant can do, and it helps you read files. So it reads a lot of files, reads them one by one, and it burns so many tokens, reconstructing its knowledge it already had 5 minutes ago. So in this project, we're going to install CodeGraph and wire it into Claude Code as an MCP server. And then we're going to run a controlled before and after comparison on a real open source code base, which I believe is going to be Excalibur. Great code base selection. And so we're going to have, by the end of this project, a pre-indexed knowledge graph, a measured before and after comparison showing dramatically fewer tool calls, tokens, and response time on the exact same question. And there's going to be a CLI-powered code intelligence queries plus a secret mission. Okay, no prerequisites other than the fact that we need Cloud Code installed and working, plus Git installed. But no Code.js, no Node.js is required. That's good news. That's very good news. Awesome, team. I'm going to go ahead and actually chuck the link to today's project into the chat. Now that it's generated, you can see this in my portfolio now. But here's also the direct link to the project guide itself if you wanted to have a look. So before we start, what are we doing in this project? Best question. In this project, I love changing the I'm to we because we're doing this together. Okay. We are setting up code graph to create a knowledge graph of a code base so that we can, what are we trying to do? Well, I like to think of it as shortening, so we can shorten the distance between our coding agents and a code base that we want to, let's say, understand, explore, or edit. So I'm quite happy with that answer. Overall, the time and tokens it should take for a coding agent to start making changes to a code base should dramatically decrease. Thanks. All right. Well, my work is starting to build already. And you know me, I love sharing my documentation literally as it happens. So what I'm going to do is I'll actually chuck the link to my portfolio from now. Look, it's looking a little bare bones right now. It's looking a little bare bones. We only got one answer so far, but with every single answer I write and I add, hopefully you can refresh and see it show up in my live documentation too. Wonderful. All right, let's go ahead and set up our code graph now. We're going to need to install code graph CLI and then clone that real code base. To do this, the first thing we're going to do is we are going to install the code graph CLI on our machine. Now, we're just going to want to make sure that we can respond to this question too. So let us say I'm setting up, we're setting up code graph and our open source repository by 1, installing the code graph CLI on our machine, and 2, clone the Excalibur repository. Exciting. Cool. Let's hit done. And let's go ahead to our first step. So CodeGraph is a standalone CLI that builds a local knowledge graph of your code. The standalone installer bundles its own runtime, so you don't need Node.js installed. Let's first install CodeGraph by running this command. I'm going to do this by opening my terminal, and my terminal looks very nice and simple, so I'm going to pick this one, and let's just run that command straight away. All right, let's paste that in. See how we go. All right. So this command downloads the CodeGraph installer scripts and pipes it directly to your shell. The FSSL flags tell curl to fail silently on HTTP errors, suppress progress bars, show errors if they occur, and follow redirects. The installer detects your operating system and downloads the correct pre-built binary, so no compilation or package manager is needed here. Oh, interesting. Cool. Well, I like that it actually suppresses. Well, I wish it didn't suppress the progress bar. I take this back. I quite like seeing the progress of something installing, but each to their own. I see that it's already done. So we've got CodeGraph installed. Is anyone else actually installing CodeGraph and following this project live right now? Because I'm getting this feeling that we could be discovering something awesome together. I have a feeling this could be a really great tool, honestly. Um, and we're going to open a new terminal window after the installation finishes, and the installer should add CodeGraph to your path, but doesn't update your current shell session. All right. So let's open that new terminal window. I think what I'm going to do is just open it like here. All right. And the installer adds CodeGraph to your path, but doesn't update your current shell session. That's cool. All right. Well, next up, we're going to go straight to cloning the Excalibur repository. So we're going to move to our desktop within the terminal by running this command, cd desktop. All right, cd classic command. We definitely want to be changing our directory, that's what cd stands for, into the desktop folder. And once we're here, we're going to clone our Excalibur repository directly into our desktop. So let's clone that straight away. We should be expecting to see the Excalibur folder show up in our desktop. So let's see if it does that. Let's hold our desktop accountable. You should be showing Excalibur. So let's see if it does that. All right. Okay. Awesome. I'm just going to make sure that once it's cloned, and I thought I should call it out. I should have mentioned this, but the clone has the depth of 1, which means that we are shallow cloning with only the latest commit. This is faster and saves disk space since you don't need the full Git history for indexing. This is actually so true. I thought I'd call out that this is actually something I've been learning myself when I'm onboarding people into NextWork. And one key thing about onboarding people into NextWork is we often think about, hey, what is the most amount of like tool setup we can already do for someone before their first day? And one of it is that we should always clone a local copy of the app, our code base, into their laptop, because when they want to vibe code something, and test out a feature in the app, they should be able to get it up and running in minutes instead of having to spend hours figuring out how to clone our app and how to run it. This means that I've actually been cloning our app into a lot of people's laptops over the last few months since our team has been growing so quickly. And I definitely had to shallow clone. It's been years of us building the NextWork app, and so the code contains so many different branches, commit histories, so much is going on that if I don't do shallow clone, the repo literally fails to clone. I often see it run for for literally maybe 10, 12 minutes and suddenly fail. And then it will say there's an index error because I think we have too many things indexed. That's my theory. So shallow cloning has definitely saved me a couple of times. All right. Well, we're going to confirm the files are present by running ls. Oh, okay. We're going to confirm files are present within our Excalibur folder. So let's press ls. And this now reviews all of the files that are inside the Excalibur folder. Because we can see the files within, this is how we can confirm that we've successfully cloned Excalibur. That's great news. We can definitely see these files. Looks like packages is here, the folder, and then package.json, our file. So these are all cloned successfully. So let's just verify that our code graph setup is going to actually work by checking for our code graph version. Ooh, we do have a version number. It's 1.5.0. This I love checking version numbers. Version numbers is just such a good way to check whether something is available or not. So shout out to whoever came up with that as like, oh, I should check a version number to see if I've actually successfully installed something. Well, I hope you can see that if you see an older version or you see CodeGraph command not found, you can easily click on these tabs to troubleshoot and get some help. Otherwise, you can use Ask as well. All right. Well, we can double check we're in the right directory by running pwd in the terminal, and we should be able to see that we're in a folder called Excalibur. Awesome. So I think that is step one all done. Ah, can we have a heck yeah in the chat or something to celebrate? Oh, I can't play fun sounds. I used to always play fun sounds in the team Discord. But I see that that's not enabled here. Otherwise, I will probably be spamming the soundboard. Well, that moves us on to step two, which is to experience the exploration tags. So our tools are ready, CodeGraph is installed, the Excalibur codebase is cloned. Now it's time for us to see what happens when Claude Code tackles a large codebase without any help. Claude Code has no memory of your codebase between sessions. Every time you ask a structural question, it must scan files from scratch, reading them one by one until it pieces together an answer. So let's experience this exploration cost firsthand. I'm excited to see this. I would really like to really experience that exploration tax. You definitely feel it when you're working with a production level code base. You might not feel it as much if vibe coded a tool in one day and you want to pick it up again tomorrow. You might find that it can actually implement new suggestions very quickly. But as you work on it over time, you might see that it takes longer and longer and longer and longer to actually implement your latest suggestions. I definitely feel this way with me trying to vibe code anything in the NextWork app now. It can take a lot longer than how long it used to take maybe 1 or 2 years ago. Okay, so to experience this text with our open source code base, we're going to just open Claude Code inside our Excalibur directory, and we're going to ask an architectural question that's going to trigger Claude Code to scan a lot of files one by one. And we need to record the session metrics. That's a great shout. We need to actually hold ourselves accountable and truly actually record how much tokens and how much time it takes so that we can reasonably compare it with our second try later on. So in this step, we're going to experience the exploration tags together. We're experiencing the exploration tags. Oh. So that we can compare it to how long Claude Code takes to answer an architectural question once our CodeGraph knowledge base is installed. Knowledge graph is installed. Man, I always say knowledge base. I guess I haven't moved beyond that era when we were creating our own AI chatbot and we had to create a knowledge base for it. I miss the Bedrock days as well. Okay, so we're going to run a Claude Code session inside Excalibur by running this command in Claude. Called Claude. Beautiful. Okay, you should see the Claude Code interactive prompt appear, ready for input. If you don't see it, here's some help. But all right, team, I think if I'm going to switch over back to my terminal, I should absolutely be seeing the Claude Code interactive prompt. Hey, and we do. That's great news. I don't think I need this other terminal window anymore, the window that I use to install code graphs. I'm just going to go ahead and close that so that we can focus on this one. Okay, well, ask an architectural question. You're about to ask Claude Code a structural question about how Excalibur works internally. This is the exact query used in CodeGraph's published benchmarks, so your results will be directly comparable. Before you send, think. How many tool calls do you think Claude will need to answer a question about code architecture in the Excalibur code base, which has 640 TypeScript files. That's a decent amount. So we're gonna type this question into Claude Code and press enter. All right. I have no clue what to expect. How many tool calls do we think Claude Code is going to use to answer this question? How does Excalibur render and update canvas elements? Hmm. It's one of those deceivingly, it's not simple. It's not a simple question. I want to say it seems simple, but it's not simple because there's so many different types of canvas elements in Excalibur. You could answer this with a lot of detail if you want to go into all the different types of canvas, with all the different types of canvas elements. Hey, Roy has dropped some interesting notes in the chat. Pairing code graph with this GitHub is how I build my visual brains. Oh, I see. That's how you build your visual brains. That's awesome. Knowledge graphs are truly becoming more and more interesting, huh? We first heard about knowledge graphs about a year ago, and I think we're truly seeing it become more and more popular as things like Obsidian and Second Brains also become more popular. Okay. Well, we're going to see what happens next. Claude is going to spawn Explore agents that use grep, glob, and read calls to crawl through dozens of files, piecing together the answer from scratch. This takes a while. Let's finish before completely moving on. Yeah, so it's going to take a long time because Claude Code has no existing index of the code base. It literally cannot answer your question without opening all the files. Well, not all, hopefully just some of them, and reading them. So, these references, grep is to find a keyword. I see. A read is to pull in a file's contents, and glob discovers which files even exist. So these all make up that exploration text that we're talking about today. Okay, wow, it's writing out a whole answer now. It used 22 tool calls. Oh, Derek says you have to drop for now. See you next time, Derek. Good to see you. Thanks for stopping by. And it used 47,000 tokens. I have to say, I was estimating a bit more than 22 tool uses. But I think it's because I expected it to need a lot more different files. But I imagine it might have used grep a bit more efficiently than I expected. Okay, there's a pretty in-depth explanation here. Excalibur renders to 2, sometimes 3 stacked canvas layers and drives updates through a version tracked scene with layered shape caching. Wow, that is relatively complex. I'm quite impressed with how it understood it all. I think what we're going to want to understand is how much it costed. So we're going to see how much it costed to actually come up with that summary. All right, that took us 89 cents. It took about 2 minutes. The API call and usage by model, Claude Code Haiku, 427 input. Oh. I think it's because it might be combining some of my usages from other sessions here. I think it's interesting that I'm seeing my Haiku and Opus usage. I think I'm using Fable right now, but we'll see if it actually used other models to do other parts of the actual solution to come up with this answer. Let's see. Oh, Sean says, I'm totally digging your background. I appreciate it. Yeah, it's one of my favorite ones. I started using it since our last live. Okay, well, I'm going to press escape to cancel this cost summary. And let's go ahead and have a look at whether we can write a summary of all of these costs in this next question. I'm not going to press exit yet because, unless I can. Let me press exit. Oh, yeah, Hmm. Well, I wish I didn't have to press exit because when I exit, I can't really see the contents of my session. And I kind of need to see it so that I can answer this next question. So we're going to bring that session back up so that we can answer the next question. The question is, what did you observe about Claude Code's exploration approach? It made approximately how many tool calls and used how many tokens to answer the question? Excellent. So let's go back to our session. Do you think we can see it again? We can. We can see that it used 22 tool uses and 47.3 thousand tokens. So let's copy that and paste that over. So it made about 22 tool calls and used 47,000 tokens to answer the questions. Um, by, I would say, reading, searching, I'll say reading multiple files, searching lots of different keywords, and exploring what are all the files in the code base to formulate its understanding of the Excalidraw repository. All right, so I think we've learned something new now about Claude Code's exploration approach. Very sweet to see Amber and Maximus. Hi. Amber and Maximus say, go Nat, and Nat the goat. We've also got Yolanda here. Hi, Yolanda. It's very nice to meet you. I think it's our first time meeting. I'm Natasha. I'm doing a project right now on CodeGraph, which is a very cool tool that I've just learned about this morning. It basically shortens the distance between coding agents and the code base. Coding agents actually take a long time trying to explore code bases today. Takes a long time to read all the files, try to understand how things work. And CodeGraph actually tries to shorten that exploration journey, or what this project calls the exploration tax, by basically storing a great knowledge graph that maps together all the different parts of how this code base works. So coding agents don't have to spend too much time exploring it anymore. Okay. If you'd like to check out the project, I'm going to paste it into the chat one more time. I've really been enjoying this project so far. I think it's such a great intro into CodeGraph. Um, all right. So we're now at step 3, and we're going to build the actual knowledge graph. So in the last step, we just watched Claude Code burn through 22 tool calls and 47,000 tokens just to answer a single question about the Excalidraw codebase. Now we're going to build a pre-indexed knowledge graph of every symbol, call edge, and dependency in the codebase. So once it's built, in the future, Claude can actually query the graph instantly instead of reconstructing and trying to re-understand the entire structure of the codebase from scratch. We're going to do this by wiring CodeGraph into Claude Code as an MCP server. And then we're going to index the entire Excalidraw codebase into that knowledge graph. Finally, in this step, we're going to verify that the graph is ready for queries. Now, you might be new to the concept of MCP if you're seeing this for the first time. And basically, MCPs are an open standard that lets AI models, like LLMs, actually securely connect and interact with external data sources, like different external data sources, tools, and services. So in this case, what are we doing when we wire CodeGraph into Claude Code as an MCP server? We are basically wanting to connect AI models that we access through Claude Code with CodeGraph. We're basically giving AI models the ability to use CodeGraph as a tool. Now, our AI models are going to want to do that because it's going to want to use CodeGraph as a tool to run through the Excalidraw codebase and create that knowledge graph. So once that graph is ready, we should be able to verify that we can use it and start querying the knowledge base and other steps in this project. So let's go ahead and do a recap of what we're going to do in this step. So in this step, we are building a knowledge graph, a knowledge graph of the Excalibur code base. And do you remember how we're going to do that? We are doing this through the code graph MCP. Oh, see you later, Amber. I was just about to say bye. Amber says, everyone's crushing it. Happy late nights studying, everyone. Nat, you're amazing. Why did I say that in a funny voice? Nat, you're amazing. See you tomorrow. Okay. So we're going to want code graph to build that knowledge base so that Claude Code can better understand the Excalibur code base for future queries. Okay, next up, we're gonna actually install code graph. We're doing this so that we can wire code graph and connect it with Claude Code. Sorry, I think I just said we're gonna install code graph because I was looking at this command here called code graph install, and I got a little confused. I thought, wait, we literally installed code graph in step 1. What's going on? But actually, the command here doesn't install code graph into our computer, into our laptop, into our device. What it actually does is it creates an MCP server entry that tells Claude Code how to launch the code graph server. It's actually installing code graph into the MCP universe that Claude Code is using. That makes a lot of sense. So let's go ahead and run this command now. Okay, I think we are not going to use this, we're not going to do this within Claude Code. We're actually going to exit Claude Code because I believe we're actually running this in the terminal as a command. And there we go, the installer is interactive. So I'm seeing what we should be seeing. It's going to give us a multi-select prompt asking which agents to configure. Okay. Okay. And cool. Which agents should code graph configure? Let's just go for Claude Code, and it even detected that. Nice. Install the code graph CLI on your path. Yes, if it's required, then absolutely. Say less. What else? Is our code graph installer doing okay? I'm not seeing anything else yet. Oh, there we go. Apply agent config to all your projects or just this one? I would just say all projects. Although it's not quite clear to me what agents we're talking about. Oh, I see. Which agent? Apply all agent configs to all your projects. I think it's because over here it actually asked me which agent should CodeGraph configure, and I said yes to both Claude Code and Cursor. And it's basically asking me, should I configure these Claude Code and Cursor settings to all my projects or just this one? I think all projects was the right choice. And then it asked me, should we auto allow code graph commands? It skips permission prompts in Claude Code. Oh, I think given how low risk this is today, I'm gonna click yes. But if this is something I really cared about, let's say I really cared about this production code base where there aren't many opportunities for people to review code before it goes out into prod and actually affect live users, then maybe I'd be a lot more careful. But I would say, given that people have good practices with Git and branching, typically if you are already using that practice as a baseline, then auto allowing commands honestly isn't a huge problem. That is my take. If you have good foundations with Git, which version controls and just make sure that any destructive changes you make is self-contained within that branch. Okay, should we share anonymous user stats? I love helping out open source projects, so sure. And then front load code graph on how, where, trace prompts, auto inject structural context. Oh, Maximus is gonna jump off. See you, Maximus. You the best. Thanks. That's very, very sweet of you. And I hope you have a good night. So front load code graph on how, where, or trace prompts. Auto inject structural context so answers need fewer steps. I feel like that is a great idea. Um, so let's click yes for that. Do you want early access to CodeGraph Pro? Join the beta waitlist. We'll only email you about CodeGraph, never share your address. No, we're okay for this. Um, so we're gonna restart our agents to use CodeGraph. Okay. Um, I think, by the way, that ideally, I don't think we need to restart anything because we don't really have Claude open in any other terminal right now. Um, so I think we're good to just continue. Index the Excalibur codebase. With the MCP connection in place, you can now build the actual knowledge graph. This is the step that transforms raw source files into a queryable structure of symbols and relationships. Make sure you are still inside the Excalibur directory. Aye aye. Confirm with PWD if you are unsure. Fair enough. Sounds good. And build the knowledge graph for the Excalibur codebase. Okay. It's going to index 600 plus files in seconds? It's that good? Oh my goodness. Let's see it. Well, it's going to initialize code graph. It's initializing, it's scanning the file 661 found. It's parsing the code. Man, it is going through this at a pretty fast pace. Whoa. This is cool. 100%. This is in seconds. I don't think that took any more than 30 seconds, team. And it's resolving references. How fast does this take? I'm quite impressed with this progress bar, by the way. These colors and like this changing status symbol is quite interactive. They're quite creative with this, aren't they? All right, quite a bit going on here, but we're getting to 100% pretty quickly. In the meantime, what is happening? Just what is CodeGraph doing? CodeGraph is parsing every source file using TreeSitter, which is a fast incremental parser. It extracts functions, classes, methods, imports, and call relationships from across the entire code base. Now, I like that it's actually extracting things like functions, classes, methods, imports, and call relationships. I can see how these are different elements of code that really can show things like dependencies or give you insight into how things work. Because at the end of the day, the functionality of um, the code base, you know, how things work can probably be traced back to a lot of these. So starting with these, extracting the functions, the classes, the methods, the imports, and the call relationships is probably a great way to start and a great way to understand your code and how things work. So let's see. It's already indexed 10,674 nodes and 45.5K edges in just 19 seconds. Yeah, that's very impressive. My goodness. Um, so everything is stored in a local SQLite database. Interesting. So no data leaves our machine. You did not need to install Excalibur's dependencies or run any build steps. CodeGraph indexes source files directly using static analysis. So we're going to just just confirm that this CodeGraph directory was created inside this Excalibur repository. Let's go ahead and go inside. We can see that if we list all files within this CodeGraph subfolder, that there is an item inside. It's a database called CodeGraph. So this confirms to us that all of those nodes and edges have been stored inside this database. And let's go ahead and verify this index. Before we run the next command, how many symbols, so how many functions, classes, methods do you think CodeGraph extracted from a 640 file TypeScript project? Let's go ahead and check the graph statistics by running CodeGraph status. Ooh, what do we think? How many symbols do you think CodeGraph extended? How many symbols? Is there any way we could guess that? How many functions, classes, and methods do you think is inside this code base? Is it possible to guess? If I were to do a rough guess on the number of functions inside 600 files, 600 files. How many classes in 600? Oh my god, it's 640 files in this TypeScript project. It has to be in the thousands because I wouldn't think every single TypeScript file would have its own classes and methods, but a file could have so many. I think my guess is gonna be it's in the thousands. Let's see what people in the chat say. Roy says 5. Shay says, "Yeah, pretty much." I love how my guess is in the thousands. Oh my goodness, what's gonna happen? All right. We can see that when we look at our status, there is an index that's showing 661 files, 10,000 nodes, 45,000 edges, and the nodes by kind. There are 4,000 imports, 2,000 functions, 1,000 properties, all of these. So every single node is one of, I guess, these attributes or these assets. What is it called? These components? Ooh, a component is actually its own node. Ooh. Oh, they're literally called symbols. So every node represents its own symbol. So we've got 10,000 nodes. Nice. That's amazing. So that is a lot of files that surface in seconds. That's wild. We've got some funny just in the chat right now of Shane and Roy going, how do we get 5? But I think it gives me a lot of appreciation for how, great products can have great user experiences and a lot of time it's hiding a lot of complexity under the surface. There are a lot of nodes and edges underneath the surface. So, CodeGraph indexed 661 files with 10,000 plus nodes and how many edges? I don't remember. Oh, logic option. Oh, okay, that's my keyboard. 10,000 plus nodes and edges, 45,000 edges. I would say an edge must be a drawing between a file to a node. I would say there must be a line between that. It must say like, oh, this file has this many imports. It has this import, this import, this import, and then this function, this function, this function. I would imagine each of those is an edge, and there are 45,000 edges. Wow, and 45,000 edges. Representing all the different symbols in the code base, plus how they're and where they live in the different files in the code base. Excellent. Okay, so we're going to ask Claude Code the exact same question for step 2 and see a difference. So we're going to see the payoff. Now that our knowledge graph is built, every function, class, input, and call relationship in the Excalibur code base is indexed into a local SQLite database, and we're ready to answer these structural questions instantly. So we're going to ask Claude Code the exact same question from step 2 and see it answer from the graph instead of scanning files this time. The difference in tool calls, tokens, and speed is the entire point of this project. Now, I do think that it would be interesting if there was some research on other ways that we could solve this problem and how CodeGraph is better than them. Because I'd imagine that tokens and token usage and getting things up to speed is something that we've already tried solving with Claude Markdown files, for example. But how is this better? So that's something I wish we could learn a little bit more. But maybe I can ask the ask feature. So let's go ahead and click ask. I am genuinely curious. How is using CodeGraph better than other solutions? Like simply creating a Claude Markdown file. Okay. In the meantime, we've got a great question from Roy saying, Nat, do you plan to use this system in your daily ops? Well, the interesting thing is, I there isn't a code base that I'm actively trying to explore and try to work with in my daily ops today. But the reason why I've been so interested in CodeGraph is because the team is really starting to jump into the code base, into the NextWork code base a lot more. And we're constantly thinking, how can we make that even more effective for the team? I'd imagine one of the ways the team can be more effective is if it's faster and it costs less tokens, of course, to answer questions. And we often rely on coding agents to help us with context and help us with how to do something. Um, so I think if that exploration tax is massively reduced, CodeGraph could be a tool that the whole team uses. So this is actually a little bit of a research project for me to see if it's something I could introduce to the team. Um, I think given my experience so far, I feel pretty good about it. I actually genuinely want to show CodeGraph to the team tomorrow as a potential way um, we could really speed up how quickly a coding agent like Claude Code is implementing solutions when we vibe code like new features or if we want to test something out. So, okay, um, let's see the breakdown between Claude Markdown files and CodeGraph. So, Claude Markdown files are like a static instruction manual or a briefing document. It tells Claude Code our preferred naming conventions. It cannot read, map, or dynamically query the relationship between files. Interesting. CodeGraph, in comparison, is a dynamic code intelligence engine. So it parses the actual code structure and builds a physical map, which I imagine is a lot more detailed than just like, a text description of how the code works together. So I can see how it's a lot more detailed, a lot more robust. Yeah, and a lot more effective at reducing that exploration tax. Every line inside Claude Markdown is also loaded into Claude system prompt context at the start of every session. So if you tried to write down all code-based relationships manually in Markdown, you would quickly blow past context limits. In comparison, CodeGraph actually stores all code relationships metadata in a lightweight local SQLite database. So data is queried on demand via the MCP tool, like CodeGraph install, meaning you only use tokens for the specific, highly relevant code snippet returned. That's a good point. The more you know, the more you know. So, the conclusion is they actually serve different needs, and we actually need both. So, we actually should use Claude Markdown to define our guidelines and standard commands. But inside Claude Markdown, we should actually tell Claude Code how to prioritize the Code Graph MCP tools. That's a great point. I really want to add this into my project. This is very insightful. Excellent. All right. Well, let's get back into it. So we're going to see the payoff by starting a fresh Claude Code session with the knowledge graph active. And then we're going to ask the same architectural question, but watch Claude query the graph. And then we're going to put ourselves to the test. Do we actually save on token calls, tool calls, and tokens? We'll have to see. Okay. So in this step, I'm asking the same question to see Claude query the knowledge graph to answer my structural question. We should see the number of tool calls and tokens required dramatically reduce. Excellent. So we're going to go ahead and start that fresh Claude Code session. We're going to do this by running the command Claude in our terminal. So let's go ahead and run the Claude command. And you will see a brief message about MCP tools being available. Do we see that? One MCP server needs authentication. Run /MCP. Wow, that's on point. That's true. So let's run /MCP. And oh, Excalidraw is the MCP tool that needs authentication. Okay, I think that's fine. I don't think we actually need the Excalidraw MCP tool right now because I don't think that's needed to create our knowledge graph today. So I'm happy to leave this one alone. I don't think we need to use it, but happy to be proven wrong later. All right. We've got some great questions in the chat right now. Roy is asking about whether I could consider using operating docs as our code base. For some of my business workflows, I use policy as code and docs as code with operational documentation stored in Markdown. I also use paperless NGX to organize and index PDFs, records, and other business documents, then connect those information sources to my agents so they can retrieve the right context when needed. That's awesome. It's a good question. I wonder how well CodeGraph can actually recognize, parts of my documentation as symbols. Um, because operations documents aren't quite written in code the same way, an Excalidraw code base might be written in code. Given that CodeGraph works by analyzing the code base and turning that into nodes and edges, what will become a node? What will become an edge for operating documents? If it's not capable of creating nodes and edges, would the knowledge graph still be useful? Those are some of the questions I'm asking first of all. But, to your point, Roy, I think it's actually very worth giving it a shot because if you don't know, you should at least try instead of doubting it. Interesting tools that you're using though. Have you used CodeGraph for operational docs yourself? These seem very interesting. Okay. I am going to ask the exact same question into our Claude Code session about how does Excalidraw render and update canvas elements. So I'm going to go ahead and just put that into our Claude chat. And we'll have to see how long it's going to take to answer the question this time. Look at that. It's calling CodeGraph, first of all, which is good news. I'm glad to see it actually using the MCP tool call and then calling our knowledge graph. I should expect it to use that knowledge graph now to get a good understanding of the Excalidraw code base. Oh my goodness. It's already done? Oh, it's already writing a response on how it works. It only had to call CodeGraph 2 times to do that. In 42 seconds. Did we just see that? Whoa, that really was much faster. Damn. It called CodeGraph 2 times. I mean, that is really impressive, I have to say. Oh my goodness, but I think I might have missed something out now. Whoops, let's move away from that. Good to see Desmond join us in the meantime. Hi, Desmond. Um, I'm so shocked, by the way, getting us back into this. Um, I am so impressed to see that Dear Call Code is now using a lot less time to answer the same question. Now, I do sometimes wonder whether any of that is because it's answered that question before and it's doing it for the second time. Does that at all impact its performance the second time round? I get a little suspicious sometimes. I get a little critical. But it really took a lot less time to do that. All right. Um, we're gonna go ahead and run slash costs in our Claude Code session to compare the same three values against what we'd written in step 2. We're gonna look at how many tool calls were required. We're gonna look at how many tokens were consumed, and then the response time, which should be noticeably faster. It took about 2 minutes last time, so I am also very curious about what it's gonna be this time. Mm. Oh, wow. Yeah, 48 cents, 39 seconds, and I don't think the number of tokens is clear. I think the number of tokens it's not very accurate. I don't remember it taking. Did it require this much input and output in the last time or no? I hope this is accurate to this session, but I'm actually not quite sure. I do have to agree though, I did notice that the time it took was dramatically less. So in step 2, we saw 22 two calls, but now 2. Yeah, this is so interesting. I think, oh, is it because no, is it because I should be looking at Cloud Code stats? Is that why I can't actually see the number of tool calls? I was gonna say I don't think we could actually see the number of tool calls just from the cost. um, just from running slash cost. So maybe we need to be loading our cloud code stats. But for now, it's not too clear. So I'll just click on stats anyway. It might make a difference, but not too sure for now. That's all right. Let's move on. After building the graph, we saw only two tuples. To answer the same question. That's so impressive. I'm so stoked. I really think this could be a great unlock for production level code bases for sure. All right. So we've got hard evidence now that our knowledge graph transforms cloud code from a file by file explorer into a tool that answers instantly from pre-index structure. Next up, we're going to use the code graph CLI to query the graph directly for caller tracing and impact analysis with 0 AI tokens spent. Interesting. Okay, so tool calls have dropped from 20 to 1 to 3, tokens plummeted, and the answer arrived faster. So CodeGraph is not just an MCP server for Cloud Code. Its CLI actually lets you query the knowledge graph directly for caller tracing, impact analysis, and affected test detection. So these queries hit the local SQLite index and consume 0 AI tokens. That's interesting. I can't wait to query CodeGraph. How does it consume 0 AI tokens? That's so impressive. What a cool way to understand the code base without consuming like AI tokens, if that's on the mind. Tokens on the mind. On the mind. Do people say that now? Instead of saying money on my mind, they're like tokens on my mind. All right. So in this step, we're using the CodeGraph CLI. So that we can query the knowledge graph directly. For caller tracing, impact analysis, and affected test detection. I gotta say, these 3 items are not clear enough to me right now. I really hope we could see an explanation. Whereas I feel like the explanations for these are, it's like, man, I'm seeing this horrible definition for every single time we see MCP. Whereas now I genuinely want to see it for caller tracing and the other words. Okay. So let's go ahead and search for a symbol by name. So the code graph query command searches the knowledge graph for symbols matching a name. You can find functions, classes, methods, and imports instantly without opening a single file. So we're going to search for the render scene symbol by running this specific command. Okay. When we run it, we should see a list of matching symbols with their file paths and types. Oh, okay. I'm quite interested in this. All right, looks like the stats is really not showing too much. So we're gonna go ahead and just exit Dear Cloud Code and go ahead and query code graph now. So we've got 2 results when we query the code graph. The first one is a function that says render scene to SVG. The second is an import, which is a renderer that's called static SVG scene. The reason why this is floated as a result is because the import is called render. We import render scene to SVG here, which is an exact match for the keyword render scene. I'm quite interested in what these do for the Excalibur code base. I wonder if we'll get to understand this more. It looks like we will start by understanding what calls this function. What calls render scene? All right, code graph callers is how we can query it. So we're gonna go ahead and run that. And now we can see two callers. There is a function and there is a file that call render scene. The function is called export to SVG, and then our file is called the export TypeScript file. Interesting. Okay, so I don't think we're still gonna be able to really have like a written explanation of what is render scene without AI, but we can really see the raw output, at least. I think the reason why this is so interesting for us to do manually is because this is probably what Claude Code is doing when it is actually calling the MCP server. I imagine it's actually using the MCP server as an LLM so that it can actually do these queries directly with CodeGraph in order to understand the code base and be able to paint an accurate picture of what's going on. Um, so we're going to run an impact analysis next. So an impact analysis is going to be a list of every symbol and file that would be affected if you change something. If you change, like, let's say in this case, a symbol called render scene. So this is the full blast radius traced through the graph's dependency edges. I love to see it. All right, let's run it. Whoa! So if we were to change render scene, there'll be 13 other affected symbols. It's a function, it's a file. Wow, all these different functions and files will be affected. This is the full blast radius. I love that. Um, I think that's a really cool, actually, that's a really cool command and query because when you are making a change to a code, like a piece of code, sometimes it's hard to understand what is the blast radius of my change. And I actually often hear our engineers talk about blast radius because it's a good way to actually explain to someone else just how much of a change this means to your code overall. Because even if it only takes, one or two files to implement a new feature, if the implementation is going to affect something else, then the blast radius is actually quite big. So I really like seeing that we can actually just find all of that with one query. Let's take a screenshot of our code graph impact output showing the affected symbols and files. Okay. But yeah, blast radius, this is something that our engineers talked with our founder Amber about a lot, to really explain the magnitude of a change that we're about to make or feature that we want to build. Uh, Roy says, I tell them, how big do I want the blast radius? That's a great mindset to have. How big of a change do I want to make? I hope it's really high. Our question is, what advantage does querying the CodeGraph CLI directly have over asking Cloud Code the same question? I think it's the fact that it doesn't cost any AI tokens. So I think it's more specific and it has 0 tokens of cost. So I can use CLI. Oh, shoot. I can use a CLI to query the knowledge base without consuming any AI tokens. We can query for things like dependencies, which is, you find that out by running the command impact. And then you can also understand callers and even just a query. Interesting. So let's go ahead and submit that. And that's it for our 5 steps today to better understand code graph. I thoroughly enjoyed this project. I think it was a lot of fun. I do have a bit more time today, so I know it's 11. If anyone is, wrapping up for their day, you're more than welcome, to take an early night. I don't think it's an early night, given that it's 11. But I'm keen to charge ahead and give the secret mission a go. So join me in the secret mission if you're keen to do something a little extra. We're about to do smart test selection with Git hooks. You have a pre-indexed knowledge graph that knows every dependency relationship in the code base. What if you could actually automatically identify which tests are affected by your changes before you push? Wire code graph into a Git hook for smart test selection. I see. So we're going to run code graph affected manually to see which tests a source file change impacts. And then we're going to create a Git pre-push hook that pipes change files into code graph for automatic test detection. And then we're going to verify that the hook runs and outputs affected tests before pushing. All right. In the meantime, Sean in the chat says that was awesome. Let's go. All right. So I'm excited to do this secret mission. It does feel like a level up because we're involving Git now. We're going to first make a trivial change and trace the affected tests. So we need a real file change so code graph has something to actually trace. You will add a harmless comment to a source file and then ask code graph which test that change affects. So let's add a comment to a source file in the Excalibur repo by running this command. This basically says we're going to pipe the words / code graph test, that's our comment, and we're going to add that to the render scene TypeScript file. So we're going to copy this code and we're going to go ahead and just paste that into the terminal. It should have gone ahead and already done that now. I know, sadly, there is no feedback or some sort of confirmation message, but when we run this next command, we should be able to see some interesting output. We're going to run code graph affected manually with the changed file, which is the render scene file, to see which tests are impacted. Okay. Oh, it says no files provided. Use file arguments or standard in. We did actually use this stdin, I think, but why does it say no files were provided? I feel like we're supposed to see the name of the file somewhere, but it's not even here. Does that make sense? We're saying git diff name only, code graph affected, and all of this, but hello. Why aren't we adding in the actual name of the affected file? Is there something else I'm supposed to add here? Well, this command doesn't seem to work, so we're going to go ahead and ask a question. First, let's try to explain the code snippet and understand it. So we're going to try and understand this. This command says git diff name only. List only the names of the files you have modified or created since your last commit. And then we're going to pipe, which redirects the list of modified file names as input directly to the next command. So we're going to pipe the result of this command into the next command. The next command tells code graph to read those file names from the standard input and uses local knowledge graph to determine which downstream files, functions, or tests are affected by our changes. Well, if we're seeing the error message, no files provided, this means that when we ran git diff name only, there would have been no results. Unfortunately, no files showed up in the git diff. Why would no file show up in the git diff? This would only happen if technically no files were changed or no files were picked up by Git. Did we initialize a Git repo here? Were we supposed to run git init at some point? Did I skip this? No, I just searched git init. But my theory is, uh, technically, if we added this comment properly, then it definitely should be a changed file that should be picked up by git diff. But if it says no files were picked up, either git diff wasn't even picking up, or like git isn't actually picking up any changes right now, or we didn't edit the file correctly. Um, how do we know this? I think we can start by actually just observing and reading the file, the render scene file that we updated. We can do this using Nano, so we can actually go ahead and try use Nano to solve this right now. So I'm gonna write Nano and try to read this file. I can see that it literally has that comment, code graph test. So that tells us that we did actually successfully pipe or add the text code graph test into our render scene TypeScript file. So that makes me very curious. I wonder why it says no files were given to code graph. Hmm. Well, I'm quite curious about the next thing, which is what happens if we were to just run the command git diff name only. Does it give us any results? No results. So git diff name only could be the problem here. I have a feeling maybe git diff name only is not a proper command. Like maybe name only isn't something that we can actually use anymore. What happens if we run git diff? Nothing comes up. Should what? Is it because we haven't initialized Git? Could that be the reason why? Um, because I feel like if we edit files, Git should be picking up on this, but it wouldn't have picked it up if Git isn't even enabled. What do we think? That's my first suspicion. What happens if I run Git init? It says we're now reinitialized an existing Git repository. So that suggests that it's already been initialized. So maybe this is not the problem either. But I'm going to go ahead and just run that same command where we echo code graph test into a new file and see what happens this time. I can see code graph test being updated one more time. So surely we'll see a git diff this time. Still nothing. What about git diff name only? Still nothing. So my suspicion is if we're actually updating files, but we're still not seeing anything show up in git diff, it's actually a problem with git diff itself, not the code graph command. Um, so we're gonna go ahead and try to troubleshoot this. This is gonna be fun. Um, let's see. Roy asks git diff head. Shall we try that command? Git diff head. We don't see anything in git diff head either. So something is up. I wonder what is going on. Super curious. It's been a while since I ran into an error, so I'm actually quite excited about this one and how we might be able to solve it. But we'll start by just giving our ask feature the high level error, which is the fact that it says no files provided. Let's see if we can even understand the error and resolve it just from that. We're going to go ahead and actually just ask, why do I run into this error? No files provided. What happened with git diff? Could it be that when you run echo, the changes are somehow already saved, committed, and nothing was showing git diff? Could that be the case? But I don't think that's possible. Is it a thing that changes would already be saved and committed and all that, so it wouldn't even show in git diff? I'm not too sure. I'm not too sure, team. Okay, so let's go check if git status is working. So let's go run git status. Git status. I'm on my branch master. I've got an untracked file. Oh, I've got an untracked file, and it is the render scene TypeScript file that we edited. It could be because we actually needed to add this to staging. So should we actually just add this to staging to track it? What happens when I run git diff now? Still nothing. Git diff name only. Still nothing. All right. Should we run code graph effect standard input? If code graph effect standard input doesn't provide any file, it won't run. Okay. Well, we'll have a go. Great suggestion from Jaden to just run this. Oh, I think it's affected, yes. So we need to write code graph affected standard input and see what comes out of this. Let's see. In the meantime, it means well, scenario B says if you already ran git add, the changes are in your staging area, which means the standard git diff will return empty. But I feel a little bit confused because we didn't add our changes to the staging area. Oh yeah, and code graph affected standard input is looks like it's stuck while running, so I'm just gonna quit that for now. We do have an untracked file. This is probably the most revealing thing right now. Um, it tells us that at least Git has been tracking this change to the file, but it just doesn't show when we run git diff. What could have happened, I wonder? Do you think we should run git diff staged? All right. Great suggestion from Roy. Let's see what happens if we especially run a command that's designed to look for stage changes. Ooh, we can definitely see a diff now. And here you can see that it successfully noticed that there was the render scene TypeScript file with the two comments that we added. This is now added to staging, and it's being recognized. So previously, it looks like because our files were untracked, it wouldn't even show up in git diff. But we needed to actually track the file by using -n or -intent to add. And option 2 was to stage the file, which is what we ended up doing. But to diff stage files, we must append the cached flag to your diff command. Okay, cool. I see. Well, this is very useful. Shout out Roy for looking at git diff staged. I think that really helped. Let's see whether git diff cached does the same thing. And then we ran that command. At least we're seeing a different message. It says no test files are affected by the changed files. So it looks like no test files have been affected by creating render scene TypeScript and also the git ignore file. I think that makes sense, but I wonder if that was the intended output. Well, the intended output seems to actually list some test files that depend on the file you changed. CodeGraph would have traced the input graph to find them. Hmm. Well, given that ours didn't, I wonder why that is. It could be that render scene TypeScript is actually supposed to look a little different. Maybe there is a file called render scene TypeScript that has a lot of code in it, and when you're supposed to add the commands, it's supposed to go into that file, but instead we created a new file. That could have been another possibility. But we don't have any test files that are affected. So I would say we are probably seeing a slightly different output to what this project guide is suggesting. But I'm keen to charge ahead and see if there's anything else we can do. Maybe the next part wouldn't be so different from the project guide. We're going to next actually create a Git hook. A Git hook. So Git hooks are scripts that run automatically at specific points in the Git workflow. A pre-push hook fires right before a push completes, making it the perfect place to surface affected tests. Let's create the hook file by running this command. Alrighty. Let's create this file, and then it says that we should copy and paste all of this code into our new file. Well, you know me, I am not going to open an editor. I'm actually going to try just use Nano to open this file within the editor and just paste that new code. And I'm going to go ahead and press exit so we can save these changes. But ta-da! Didn't need to actually go into the code editor just to paste that script. Then we're going to use this command to make the hook executable. So let's go ahead and run this. It should make the pre-push code that we just pasted executable. Now, if you're curious, git diff name only head one. My goodness, quite an interesting combination of words there. List files changed in the most recent commit. That list is then piped to CodeGraph, which traces the dependency graph and outputs just the affected test file paths. If any affected tests exist, the hook prints them and suggests a command. It then exits so it never blocks the push. So all this script is trying to do is list files that were changed in your most recent commit. And then it's going to go ahead and pipe that into CodeGraph to see which test files will be affected by some of the files that you've changed. The hook will print that file, print that list of files into the terminal, and then it's going to suggest a command for you to run to test your changes. And then it's going to exit so that at least it wouldn't push any of your, it wouldn't block any of your commits and you pushing your commit into your GitHub repository or your cloud repository. That's pretty interesting. I think what we're going to do is actually go ahead and commit some changes. I think that was the difference, team. We actually needed to commit the changes and not just stage them. So let me try just fix the previous issue, which is commit. I'm gonna do the sneaky test message for my commit message. And then we're gonna try run that command again for git diff. Name only, CodeGraph affected, standard input. Oh, now it says no files provided. Okay, I have the wrong guess. I thought committing my changes would actually make the previous command work, but I was wrong. My bad. Okay. All right. So we're gonna, looks like I've already committed some changes, so I don't need to, oh, I do need to actually still run git add a. So some of the latest changes we just made, which is creating that hook, hasn't been added and committed yet. So we're going to go ahead and add and commit that. Let's go ahead and paste that into the terminal. And um, it looks like it's telling me that my working tree is clean and there's nothing for me to commit. I think there's a good chance that the hook has already been committed. Yeah. Oof. Let's see. Maybe instead of git add, mm, git add dash a should have actually included our hook file though. So if it doesn't, what's going on? Let's see. Hmm. Is that right? Oh, let's see if there's a git diff. Git diff staged. There's nothing staged either. Ooh, something is up with Git today. Roy says Linux users will be so proud I just used Nano instead of a text editor just now. So true. My goodness. What do we think, team? Why do we think that we can't actually see the see the commit message or see that we're adding our change to the hook in our commit history? I'm not too sure yet. Um, why do we think that happened? Commit our trivial change. We did change this. We did change our hook. So I would have thought that this would have been, the git diff would have been stored as well. But I'm not too sure why it's not. We're going to go ahead and just make that other change. I've just added a new line character. I wonder if this is going to be recognized. Git add, git diff staged. No changes are showing. Maybe I should write git commit, but if it's not staged, it's not staged. Nothing to commit. The working tree is clean. Hey, what's going on, team? Should we at least test the hook by running the script directly? Let's test our hook. Did that work? I'm not too sure. Ooh, this is. You should see the output listing the test files affected by a change, along with a suggested npx vitest run command. The hook is now active for every future push in this repository. I'm a little stuck. I think ever since from up here, the code graph affected command, I don't think that worked properly. Okay, Jaden asked, can you do git status? Of course we can, Jaden. It's git status says I'm on branch master. The branch is ahead of origin master by 1 commit, and there's nothing to commit. Our working tree is clean. Jaden says, oh, you did do this earlier. My bad. That's no worries. I'm glad that we're putting our heads together for this. Well, I'm gonna see if I'm going to see if we should, if we could at least get this command to work first. Maybe we can go and try add another comment into this render scene TypeScript file. Okay, and once that's added, see if there's any way if we can even just get the code graph affected command to work. First, we're gonna see if we can get git diff name only to work. Oh! Git diff name only works now. I didn't do anything different though. Uh, oh, I really don't think I did anything different, but now I can see git diff name only. That worked. And maybe I should try the full command now, git diff name only, and then pipe that result into the code graph effective command. So let's see the outcome of this one. It's still saying no test files will be affected by the changed files. But that should be okay. I mean, it makes sense if no test file gets affected by a command. I mean, a comment. So that actually makes sense to me. We've got Hampton that just joined, by the way. Hi, Hampton. Nice to meet you. Um, but let's go ahead and create that pre-push hook script again. Can we try to create that one more time? Let's open this up. Nano, git hooks pre-push. And you know what I'm going to do? I'm just going to literally just delete all the text in here and save that. So at least we've got something to save. But let's see. Let's see if that's going to do anything. Surely if I do git diff now, if I were to do git diff now, it doesn't detect any changes to the hook file, but it does detect changes to our code graph test. My suspicion is that Git is not initialized in the .git file folder. Like it's not tracking changes i- in the hook subfolder or like in the Git subfolder. That could be one of the reasons. Um, but let's have a go at running that command one more time. Git diff name only, code graph affected, standard input. Okay, nothing is changed. Um, hmm. Well, let's go ahead and paste this all the way back. I wonder if this will change anything. Let's have a go. Let's give it a try. We've got the hook, the script for the hook back now. And let's try and make the hook executable. And finally, we're going to commit this trivial change so the hook has something to compare against. Okay. So we've just committed test code graph hook. It says one file has been changed with one insertion. But I think we know that the insertion was actually just this code graph test comment. It wasn't actually detecting that the hook has been created. That's okay. I think we can still test the hook by running the script directly. Let's see what happens. Nothing happened. I think we still have nothing show. You should see the output list the test files affected by a change along with a suggested command. Yeah, unfortunately, I don't think that that worked for us. So maybe we can actually first use ask to mention that it keeps saying no test files were affected by the changed files, and maybe ask for a more dramatic change to the Excalibur code base so we can actually try see if we can see tests being affected by a more dramatic change. Um, so let's go ahead and perhaps make a comment here. So maybe our new comment says, can you please give me a more dramatic change to test? Let's see. I don't think adding a comment could necessarily change any test files anyway, which is why it would actually be quite reasonable if it tells us that no test files will be affected. So I would like to actually have a go at testing a more dramatic change to the code base and seeing if that can actually affect a test. So, okay. If you want to see a massive list of affected tests, we need to modify a file that is being imported by almost everything in Excalibur. A perfect candidate is the core constants file. Run this command to append a comment to the core constants file. All right. I think we're going to first just double check this file even exists. So we're going to go ahead and try to list all files. Let's try list all files in here and see if we can find the constants TypeScript file. So let's go ahead and run ls list all files under here, packages Excalibur. Can we see constants? Can we see constants? Um, I don't actually see a constants file. So I have a feeling if we were to try create the constants file or if we were to try edit it, it wouldn't even show up here, which would be a bit of a shame. And so we can be clear and say, hey, I don't think I see this file. Ooh, Jaden says, does your project have a git ignore file? Oh, it probably does. Can you check if the files actually exist in the project? Nano can be kind of messy with that. That's a good point. So maybe I should stop being so stubborn about terminals and actually just open up the project in Cursor. Fair enough. That's a good call. I should have thought of that. Thanks for the shout, Jaden. That's such a great one. All right. Well, it looks like the contents file might be nested inside a subdirectory or structured differently in this version of the Excalibur repository. So maybe let's just go ahead and give and try insert a comment into another file, this time called the types.typescript file. All right, so let's go ahead and try that. I think we can validate that types.typescript actually does exist. So we can go ahead and just add that comment into the types.typescript file. Then what should we do next? I think we can go ahead and try use that git diff name only command. This time it should really show which file has been affected. Yes, it does show. It shows that the types.typescript file is being affected. So let's see if the rest of that command actually works. Let's see if we can now run that analysis using CodeGraph on what gets affected by this change in the types.typescript file. I mean, it's taking a bit longer for a response. So this could be, we see something, team. Oh my goodness. We see 111 affected files. If we were to change, well, now that we have changed something in the TypeScript file, we can see 111 affected test files. My goodness. So I think that kind of validates what we were talking about before, that one of the reasons why no files came up in our previous attempts is because we were actually just adding comments into a completely new file. I don't know if you guys can remember this, but when we were trying to read the file that we added comments to, that file was empty. It only showed the comments that we added, which suggests to us that that file didn't actually exist before we created it using that echo command. And so, because that file didn't even exist before we created it, none of the tests would be affected. There would have been no other file that was relying on a file that only just, just came to existence like a second ago. So I think it makes a lot of sense now why it kept saying no files would be affected. It seems like there would have been an error in the project guidance, and it would have been referencing a file that what didn't actually exist. Clearly, it tried to do the same thing just a second ago by trying to reference a file that, that core contents file that didn't actually exist, leading to the rabbit hole that we went down. But I think this little journey of trying to troubleshoot has definitely taught us something new. Well, I'm really glad to see that code graph affected command really working now. And what do you think is going to happen if we were to try and run our hook one more time? I'm curious. Oh, there we go. Oh, now that I've run my hook one more time, I can really see the hook working. It says test affected by changes. Ooh, all of these different tests will be affected. So it gives me consider running the vitest command. Ah, this is exactly what the project steps were telling us about. Oops, press the wrong button. Um, oops. I always do this. um, but now when I go back to the secret mission, it all makes so much more sense. Um, I can see the output listing the test files affected by our change along with the suggested command. The hook is now active for every future push in this repository. So we're going to take a screenshot of that output from running that hook, and then we're going to wrap up this project today. Oh man, that was a lot of fun. I think we took a little longer than an hour today, but I had so much fun. I learned a lot too. So in this project extension, we learned that CodeGraph Affected works by, how does it work? I think it works by understanding all of the edges that connects a specific symbol to different files in the code base. So when we run CodeGraph Affected, we can see the affected test file paths. Nice. The affected test file paths from the change that we're about to make. Sean, Sean types use Whisper. Literally, I was thinking about that. I was gonna use Whisper, but not gonna lie, I quit so many apps so that the stream wouldn't be too interrupted, by all the other apps that could be running right now. I'm a big fan of Granola. I'm a big fan of Whisper. Well, I'm a new fan of Whisper. I finally got into Whisper like this week, but if it was running, I have a feeling my stream might be a little bit more glitchy, unfortunately. Okay, so we're up to the delete step now. So this is where you can delete everything. You can pause and come back to it later. You can choose to keep everything running. Just for the sake of learning together, I think it's always good to have a look at deleting everything together so that you can know exactly how to keep everything clean. We're going to go into our terminal and delete our Excalibur folder, um, which is the oh my goodness, which is the open source repository that we cloned today. And Hampton, good to see you, Hampton. It's nice to see you say you're a fan of Whisper. How long have you been using Whisper for, Hampton? Okay. Next up, we're going to uninstall CodeGraph from all configured agents and remove the CLI. So we're just going to go ahead and uninstall CodeGraph as well. All right. I think we've gone ahead and uninstalled CodeGraph from all projects. And it asked me, do you want to also remove the CodeGraph CLI? We're just going to say yes, just to really keep things clean. But yeah, just like that, we've uninstalled it. So it's just going to go ahead and uninstall. In the meantime, we can wrap up with our last 3 questions for today. So key tools we used include, what did we learn? I think we learned about knowledge graphs. We learned about dependencies, symbols. We learned about functions. I would say we learned about nodes and edges. Key concepts we learned. Oh, that was a key tool. Sorry. The key tool we used include Claude Code and Open Code Graph. So let's go ahead and write Code Graph and Claude Code. And I'm going to paste that list of things that we talked about under key concepts we learned. All right. Next up, how long did it take us to complete this project? I think this project took us approximately 2 hours because I was a big yapper and I really wanted to talk through all the details of this project, and we also got stuck. So the challenging part was the secret mission, where we needed to make changes to files that genuinely would impact or affect other test files in the codebase. We were led down a path of errors when we made changes or we created files that wouldn't affect those test files. So we did this project to learn how to be more efficient, be more token efficient using CodeGraph. I think another skill we want to learn is how we could apply this to absorbing and writing text documents. Not just code. Kudos to Roy for inspiring that one. All right, team. I think that's a wrap on everything. We've supercharged Claude Code with a pre-indexed knowledge graph that eliminates the exploration tax on every future coding session. Let's do this quick quiz with just 4 questions to test our knowledge. First, what is the difference between the code graph query and code graph callers commands? Query changes the source code. That's not true. B, query only works on TypeScript files. I don't think that would be the case. C, query uses AI tokens to search. We know that query doesn't. D, query locates where a symbol is defined, while callers traces functions that depend on or invoke that symbol. I think the answer is going to be D in this case. So let's go ahead and click on that. Awesome, that's the correct answer. The next one, you're on your own. I'm only going to read the options and you're going to have to answer. Question: how does CodeGraph determine which tests are affected by a modified source code file when executing CodeGraph affected? Does it go A, it relies on manual tags like //test written at the top of every source file? Or is it B, it just runs the entire test suite and monitors which files are touched in real time? Is it C, it searches online repositories for matching test patterns used in similar open source projects? Or D, it traces the import and dependency graph that we built during the indexing stage to identify test files that import the changed code? All right. Which one is it? Is it A, B, C, or D? How does CodeGraph determine which tests are affected by a modified source file when executing CodeGraph affected? All right, team. The correct answer is actually D. It traces the import and dependency graph built during the index stage. Okay, question 3. How does the CodeGraph installer connect its graph-based features to Claude Code? Ooh, is it A, it registers CodeGraph as an MCP server? Is it B, it uploads the code-based schemas directly to Anthropic's hosted servers? Imagine we just upload the code-based schemas directly to Anthropic's hosted servers. Don't forget that one big thing that we talked about in this project is that the code-based schema lives locally so that it is still private and secure. Or is it C? It recompiles the Claude Code executable to include the code graph binary? Are we literally going to recompile Claude Code and how it works? Or is it D? It replaces the default terminal shell with a custom code graph terminal. Um, it'll be interesting to see how D could actually connect code graph to Claude Code. Notice how Claude Code isn't quite mentioned in D at all. So A, I think, is going to be our correct answer, registering code graph as an MCP server, and it is correct. Nice work, team. So we're on our last question now. It's why does Claude Code typically require a high number of tool calls and tokens to answer structural questions about a code base? Is it because A, Claude Code has no persistent memory of code base structure and it must scan files from scratch each session? Is it B, Claude Code actually relies on cloud based indexers that copy all code base data to external servers? Is it C, Claude Code is forced to compile the code base before answering any architectural questions? Or is it D? Claude Code cannot read TypeScript files without converting them to JavaScript first. Well, we can't assume that all code bases use TypeScript files, so that wouldn't be a great response to why Claude Code typically require a high number of tool calls. But that brings us down to A, B, and C. Now let's look at C. Claude Code is forced to compile the code base. Luckily, compiling isn't quite required to actually answer any architectural questions. Um, I think you shouldn't need compiling. You actually need to actually just read files to understand the code base and answer these architectural questions, whereas compiling is associated with actually running the code. So we can ignore C. B says Claude Code relies on cloud-based indexers that copy all code-based data to external servers. We again don't need to move our code-based data to any other device or server other than your local machine. So the words external servers in B is giving me alarm bells. I don't think this is going to be the right answer. That kind of process of elimination takes us to A, that Claude Code has no persistent memory of code-based structure, and it must scan files from scratch every single session. Now, this seems like our correct answer today. It is very true. We've learned that Claude Markdown files don't really solve the problem. And so we actually need something like CodeGraph that can provide that persistent memory of how the different files and symbols relate to each other so that we've got persistent memory, which means a memory or an understanding of the code base that lasts even after you finish your Claude Code session. So that is the correct answer. We complete the quiz with a perfect score. Damn, team! That's a pretty good result. And I think we're ready to go to share our documentation. I'm so proud of this team. We did all of this in the 2 hours that we completed the project. And you might remember that at the very start, this was pretty empty. We can, of course, share this on LinkedIn already, which you can see as a post like this. Oh, is the post coming? Post is taking another second today. All right, the post is going to take a little bit of a second. That's all good. And then we're gonna go ahead and actually maybe even download this as a PDF if you like to see it as a PDF. And finally, I think something that we should definitely check out is how our our portfolio has been updated. You can see that in all completed, I started today's session with 32 completed, it's 33 completed now. And under all authored by me, I can see that my latest project is at the top of the list. Awesome work. Oh my goodness. I'm very, 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 very proud of us. We love to see it. Now, of course, don't forget that you can always do this project too. It's been generated by me. And I'd be very excited to see who else is going to be supercharging Claude Code with CodeGraph as well. So that's the project guide again here in the chat. And I hope everyone enjoys learning. Um, oh, our LinkedIn post is working too. Nice. Nice. Good to see that the entire LinkedIn post is working and it looks great. Awesome. I'm gonna stop my screen share now to say bye to everyone. Well, I really enjoyed today's session. It was so cool actually learning about CoGraph with everyone. I really enjoyed the experience. I think being hands-on feels awesome, and I can't wait to do it again in the next Build Lab. A big shout out to everyone for stopping by as well. It's literally approaching midnight over here in Texas, and I know a lot of us tuning in is actually in Texas right now. So thanks so much for the time. Thanks so much for keeping me company and working on this project together. And I can't wait to see you in the next project. Happy building and happy learning, everyone. Thanks again for stopping by. Can't wait to check out your project and your portfolio. All right. See you. Bye, everyone. Good night, everyone. Thank you. See ya.